we're going to be talking about California BIMin and TWINin from Digital Twins and the Los Angeles Community Colleges. And we've had 4 sessions. The first day we were with the Building Smart International, talking about a data as an asset with the National Institute of Building Sciences. And then owners and standards and digital twins. And just before this session, Roger Grant, the National Institute of Building Sciences, talked about the new National Digital Building Information Management Standards. And today, on this session, we're going to be introducing what the Los Angeles Community College District has been doing with BIMs and digital twins. So LA Community College, LA Community College District, LACCD, and Build LACCD is represented here. So thank you for coming. And we have, I guess we could each stand up and just do a quick introduction. That's probably the best way. Peggy, let's start with you. Welcome, Peggy.
So, hello, Fanny. Hello, Roger. My name is Peggy Quijada. I'm the Director of Facilities Planning and Development.
James Conway, Maintenance and Operations Standards Coordinator.
Good afternoon. My name is Sunil Shah. I represent the Program Management Office and oversee the district's smart building strategy.
Thank you. And I'm Kimon Onuma Inc., and BIMstorm BIMgenie. So the agenda for this session, we're going to start with Peggy, who's going to give us an introduction to the LA Community College District. And then we're going to give an overview of our view of digital twins, the digital twin ecosystem. And then James is going to talk about the BIM standards, the use of BIM at the LACCD and Build LACCD. And Sunil is going to talk about connected facilities. This is essentially how the digital twin comes together, I guess, when you start connecting information. And then James is going to talk about the facility lifecycle implementation, the actual implementation of using BIM, GIS, and CMS systems and having real-time data flow together. And then we're going to do a little live demonstration. So let's start with Peggy.
Yes, so our mission is to foster student success, empower students to identify and complete their goals, to improve the social welfare, to enhance the local economy, and to close the persistent equity gap. So I think we take this to heart, to all the things that we do, and to prepare the future community leaders. And it's really nice to walk the streets from Los Angeles and see the opportunities that the community colleges give to young people. So everybody, our goal is really to bridge that gap. Now, our goal, the facilities planning and development is divided into 2 groups. One group works on existing facilities, and that's facilities planning and development. And the other group works with capital construction programs, and that's Build LACCD. And we, in existing facilities, we have deferred maintenance projects, scheduled maintenance projects, hazard mitigation, and M&O projects. With new buildings, what we do is we construct buildings, replace existing buildings that are already obsolete. And one big thing that is uniting us is sustainability. Our goal is to improve, restore, and lengthen the health and functionality of the portfolio of facilities by implementing initiatives like, again, capital construction, scheduled maintenance, deferred maintenance, hazardous materials removal, maintenance and operations, and energy efficiency and sustainability. You can see that LACCD has 9 colleges and satellites. We cover a vast area of the LA Basin, and we have approximately 12.5 million outside square footage that of facilities that are spread over 9 colleges. These 9 colleges are divided into regions. There are 3 regions. In 2020, in July 8th of 2020, we passed a resolution for clean energy. Our goal is to have 100% renewable carbon-free electricity by 2030 and 100% carbon-free by 2040. And we have put aside $75 million to achieve those goals. In the Build LACCD side, we had passed 9 bonds since 2001. That represents $9.6 billion, and that's being invested in 737 completed projects and 231 currently ongoing. These are some of the examples of the buildings that are all currently ongoing. For instance, in Harvard College, we have the Southwest Hall. At Trade Tech, we have the Media Arts Building. At City College, we have the Cesar Chavez Replacement Building. And at Valley College, we have the Academic Complex. And here's another one, Valley College Academic Building number 2. The main challenges that we have with all these 12.5 million in square footage is decreasing budgets to maintain these buildings, silo data, meaning we have something about temperature here, something about security there. Natural hazards, exposure to earthquake, floods, and wildfire. Also, we were not foreign to the great resignation given by the pandemic. I mean, 62% of our workforce retired or resigned in the last 2 years. And other challenge is the exposure to active shooters, vandalism, and cybersecurity. So those are our challenges. Now, our priority is to use our resources in the best way possible. 95% of the total cost of ownership is in maintenance and operations. We need to utilize the current data, historical data, and associated operations and maintenance processes to provide feedback and do predictions on how to operate and determine the life cycle of our buildings. And we need to enhance the decision making at district and campus level and engage our stakeholders. So there is where it comes the digital twins. One way that we see to overcome all those challenges is to use technology. And so that's where we have an open platform. We need to integrate the systems, organize the data, enhance the performance of our portfolio, and use the data to make real-time data to make decisions and secure cost savings. So that's more or less why I'm here, just to explain to you what we have, our challenges, and the only way that we see to overcome those challenges is through technology. Our mission is very important. It's not only about buildings, it's about lives, it's about people, it's about students. And I think what we're doing is very important. And that's why Kimon has been instrumental to what we're doing, Sunil as well, and James, and that's why we're here. We want to share with you what we have done.
Thanks, Peggy. The last few days, there was a lot of discussions about what a digital twin is or isn't, and I just want to give you my view on it as I introduce this next section about how digital twins are being applied and used at LACCD. So there's some concept that you have to have a single source of truth, which is true, but it's not really a single model. It could be a lot of models that are connected and talking to each other. And sometimes it doesn't even have to be a model. It's actually data that has part of the digital twin ecosystem. It can be many applications, but multiple sources of truth. Would that work? Or a collection of disparate files with specialized proprietary tools? That's actually what we're trying to get away from. We don't want to have multiple data and multiple sources and proprietary formats. So let me give you some background of how this is being accomplished. And I think what LACCD is doing and what the state of California is doing with Fusion is in many ways one of the more advanced examples I've seen of actual implementation of live connection of their data to the models. It's not doing everything, but it's doing something that's sustainable. And that was a discussion in a previous session. If you build a perfect digital twin, how do you maintain it? If you can't maintain it over time, the data starts to rot. It becomes old, so it's no longer a digital twin. It's just a snapshot in time. So starting from the state level, there's a system called Fusion, and this happened over a decade ago. They have a huge inventory of buildings, 5,000 buildings, 72 community college districts statewide, 90 million square feet, serving 2.75 million students, which goes up and down with demographic changes. They also have real-time data available by web APIs. And what I mean by that is that their Fusion data is not trapped in a system that only certain people can get to. We actually helped them implement this over a decade ago, guiding them to create what's called a web service to push their facility inventory data out that can be used by other applications so you don't have to duplicate the data. And all of this really supports digital twins. So what is Fusion? It's a system that standardizes and streamlines the management of college facilities statewide. And it was built to support the capital renewal program and to be able to look at it from a state level to design and track projects and make decisions about capital construction projects based on what the existing inventory is and for planning new facilities. And it works in a browser and on mobile devices, which means it's accessible to non-technical users as well, which is also critical. It can't be just a techie's view of data. So this is kind of one of the windows of Fusion, but I'll break down the modules. There's a space inventory of all the spaces in the 5,000 buildings, every single one. And the reason it's there is they want to be able to track and make decisions on how much space do we need, how much is being used so we can decide what to do with it, how much is being used so we can fund new construction, how much is being used or underutilized, and how many students are in the space. What's the condition of the buildings? There's an assessment module, condition assessment related to the building. And this is statewide with 5,000 buildings, which is phenomenal, actually, if you think of it from a perspective of data that's accessible in a digital format statewide. There's also a planning module to then submit, each district can submit plans for approval and track the status of the approval and track the project using the same language, the same data language about IDs of spaces. And then you can track the projects as the projects get managed and maintained over time. And then there's a scheduled maintenance portion for each district to report and submit schedules of what's going on, of how their facilities are being managed. So we honed in on the space inventory data because it was a database that initially was only available to the Fusion users. We said, what if we open up that space inventory as a web API and publish it out so others can use it and build functionality on top of that? So we're all talking the same language. Are we in room 254A or B here? I think this is the room we're in. So having that simple ID available to everybody makes that possible. And that becomes the ecosystem, the foundation that allows all this to kind of function. It's like a set of Legos that speak to each other and can share resources and share information across different modules within Fusion. So with that Fusion data, we said, okay, what if we can open this up and make it accessible to other applications? So we suggested over a decade ago, what if you build a live web API to Fusion since 2011, and then with that API, other applications can link into it. They also had a GIS and BIM and CAD and GIS information to a certain extent, mainly GIS. So there's different modules that were relying on the same information. And then Build LACCD had additional data, which is the interesting part. You had a separate system with the same IDs about the spaces that some came from BIM, some came from CAD. They were all in GIS. They had the right room numbers for the 742 buildings. And our recommendation was then to use, this is our server in this case, and we said, let's not duplicate that data. Let's read the exact same data that's coming from the state level that's aligned with the district and LACCD, build a BIM server, which allows the digital twin to function, and build functionality on top of that. The BIMgenie is a facility management work order system, which we'll talk about a little bit later, and Dabblefox is a custodial planning system. Both of these applications did not have to replicate the room numbers. As the room numbers and data changes at the state level in Fusion, it goes all the way up in real time to this facility management application, which means we're talking about the exact same room, and the maintenance and the ownership of the room numbers, and actually the room names and building names, is at the state level in Fusion, but also maintained by Build LACCD and LACCD as information gets updated. So we're all talking the same language. This is a standardization approach. It sounds very simple, but we haven't seen any other owner implement it at this scale, meaning over the entire inventory in real time, accessible through a web API. And we've used this example over and over again. In fact, with Roger Grant and the National Institute of Building Sciences, we presented to other federal agencies how this is being used and could be duplicated and used by other owners. It doesn't sound exciting like a 3D walkthrough and everything, but it's the same type of approach. If we have consistent data, we can build new applications, including 3D walkthroughs and VR and AR on top of that, and all the other great things that the detailed digital twins can do. And most importantly, these are like Legos. You can build future functionality on top of that. You can say, I need another app to do whatever it might be. They don't have to build the whole infrastructure from the beginning, and they can rely on the same information. And it allows the owner to own the data. In other words, we don't own the data. LACCD owns the data. Fusion owns their data. So if they want to replace us and put another application in, you just pull that Lego piece out and bring the next Lego piece in. Real-time access to data is what was defined as a digital twin the last few days, and this is an example of that. So these just plug and play together, and that's the exciting part. And what Peggy described as far as the bigger vision of the digital twin, there's a lot more that can be done beyond this, but not having this base level functionality, it's just meaningless unless we can use the same data. And over the years, we have seen failures of owners that have tried to do too much, and then they can't maintain the buildings. So it's not the best approach to say, hey, I want a Ferrari, but I have a dirt road. Okay, let's start with the bicycle and make sure we can get across the road in the bicycle and build incrementally over time. And that's a huge mistake, I think, in the industry without looking at a holistic approach like that. So we know where this all came from. We have these challenges we've heard about proprietary islands or silos where you have the different phases of design, owner requirements, planning, design, construction, installation, operations, and the smart cities and everything. How do we break these islands? We start talking the same language. We're using standards. We're using standards such as IFC and COBE, but there are a lot of other standards, the ISO standards, the owner standards about how owners call their buildings and spaces, what type of attributes are important for their assets. There are simple standards just like CSV tables that if you have tabular data, or web-based applications, or the WC3 standards from the web and how our mobile devices function. XML was mentioned earlier, JSON. So there's a lot of different ways to have these conversations between different applications. But the building industry mostly has relied on standards to do information exchanges, to pass my data from my application over the fence to the next application. They can use that same data. Incredibly important, but it's not real-time digital twin data. It's basically file exchanges and extraction and import, which we absolutely do need, but we also need to think in terms of how do we get real-time data, machine-readable, real-time data that digital twins define as kind of the ultimate, real-time access to information, and how do we control the security and access to this information at the data level, not at the application. You don't lock the information at the application level. And this calls for open data exchanges, for web APIs, it sounds like science fiction, but we rely on it every day now with our mobile devices. That's how our mobile devices can find an Uber ride, that we don't have to build our own satellite system. We're using the Department of Defense satellite system to call Uber. We're using location to find the space in the building. In fact, I sent you guys a link with the latitude and longitude to find the space because the information in the conference is not great about where are we in this building. So that technology is what I think is the most exciting for us from a digital twin perspective, that it doesn't really stop at the building, it doesn't really stop at the infrastructure and the horizontal infrastructure, and doesn't even stop at the typical uses that we think for digital twins. It stops at the end user trying to find an Uber in the city next to a building, or trying to find a space in the building, or trying to find a facility management application in it. So we used this model when we first suggested to Fusion to open up their data about their 90 million square feet, which is a huge asset. And we said, okay, if you give that access to us at the state level, we can put dots on a map. We can put buildings on the map. We can put spaces in the building. If there's a CAD or a BIM file that shows the shape of that space, we can link that to that same ID, and we could put it in a web browser and see it in real time. If the name of the building or the space number or the condition of the space gets changed at the state level, we see it in real time on a web application that is controlled by another owner. The authoritative source of that space name and number is at the state level and at the district level as these updates happen. And we use that to then say, okay, what if we build applications to do facility management with the same data? There's no reason to reinvent space names and numbers. There's no reason to do a BIM exchange and export the data from one application into a facility management application. We read it in real time. And I'm going to keep emphasizing that because that's the most important aspect of this. We don't want to constantly be importing and exporting because that is not scalable over time. It's prone to error, and it goes against what we already used to doing with our mobile devices in real time. So this is, I'm not going to read every bullet here, but this is the history of the whole evolution of Fusion. When we first got in there, it was sitting on a Microsoft SQL server, accessible only to 2 or 3 technicians there, and then the 50 or so users of Fusion. Then we said, why don't we open that up as a web API, give access to the districts, which actually own this data. The districts own the data in Fusion, and let them use it to build functionality on top of, and let other applications, including potential competitors to what we do. We're fearless about this. It's not really just about our application. It's about how can we expand the value of that. And so with LACCD, we said, okay, we have your 742 buildings and 1,170 acres and 5 million square feet or 10 million square feet, 10,856 rooms in Fusion. And we have them located on a map. You have CAD, BIM, and GIS files of the shapes of the buildings, which you've over time have updated. And we can import those to use those as a base for the facility management application in real time. So there was a lot of work kind of coming to this spot to get the buildings in order and the desire to connect them all together. And there were the standards that were used internally. And James, I think you're going to talk a little bit about how that was done and how we got to this point.
All right. So James Conway, Maintenance and Operations Standards Coordinator. And I want to start with a quote from our BIM manager, which is, you know you have to do BIM, but do you know why you have to do BIM? And we've been doing BIM for over 10 years, and that list of goals has been constantly growing. And the common ones are obviously collaboration, design, construction, coordination, 4D coordination. But now we're getting really into sustainability, energy management, GIS integration, FM integration, and DSA submission. And all that is centered on the BIM model, the authoring file. And these are all the areas that we're tapping into that BIM model. And we're I'm going to focus later on the maintenance and operations side, because that's the area I handle the most. But we're constantly growing this list, and we want to get also more efficient in each of these categories. Our BIM standards are public. If you go to the Build LACCD website, you can go to standards and guidelines, and you can look at our BIM standards and our CAD standards. We're on version 4. Version 3 was very prescriptive. When we went to version 4, we kind of lightened up the COBE requirements and the IFC requirements and the Omni class, but now we're hearing that COBE is going to get updated, so I think that's going to be more in line with our latest version. So once the COBE update comes out, we're probably going to migrate to version 5. And we police all this using our BIM forms, which are also accessible to the public if you guys want to view. Obviously, one of the main important factors for using Revit and BIM is for clash detection. But we also use it to make sure our M&O staff member has access to all of our systems and make sure we have enough clearance. We color code all the systems so we can show that to our M&O staff and they have a better understanding of what they're going to inherit. All of our model has extensive data requirements. I mentioned we do IFC, we do Omni class, and we're constantly checking to see if the data is all in there so that we can use it into our work order system. One key area of all that is the space requirements. We constantly checking to see the space are created correctly in Revit for an energy management standpoint, but also again for the Omni class classification, and most importantly for our space utilization, which is going to be for our Fusion space inventory. And again, we export all that information in a COBE file that goes into our work order system. And obviously, the goal is to have a Revit model be the closest to what you're going to inherit in the real world. And Sunil, do you want to talk about our Build LACCD?
Thanks, James. So connected facilities is tremendously important to LACCD. In order to utilize the data and the modeling information that Peggy, Kimon, and James spoke about, we really need to focus on the smart buildings, the network connectivity, and all the sensors and how they connect over a converged backbone. And my role with the build program is helping to design and construct those facilities and that digital infrastructure. We've been on this journey for well over 10 years, and it was a big challenge at the beginning. We had several networks in each of these buildings, and the data was in silos, very difficult to access. There were analog systems out there. Video surveillance feeds would be located inside of a building, and our public safety personnel would have to literally go to the building to go access the feed, and it wasn't really a good quality feed. And we had proprietary protocols out there, and we've changed all of that as of recently and over the last 10 years. So as part of the digital transformation, we had a number of drivers that we had to focus on to make those changes. The first, like what Peggy and James talked about, was that the data was essential. We needed access to good, clean data. Having that information can allow the facility staff to react quickly and efficiently to resolve issues in the building. We also had to look for cost savings. So utilizing digital technologies, we're able to save costs, and we've been able to prove that with the connected facilities that we've put out. We also wanted to enhance the learning experience. Students, the 21st century students, need access to robust, high-performing internet networks to access their academic applications. But also the facilities need to have the ability to be flexible, so we can integrate new ways of learning into the classroom, like nursing simulation labs, augmented reality, and virtual reality applications. Of course, our buildings need to be safe and secure, and we do that with a combination of technologies and physical security. And then, like we talked about recently, sustainability and energy measures are a huge goal for the district, and the electrification of our systems, moving away from fossil fuels. We also need to report on that and validate how we're doing on the energy front. So using our digital technologies is very critical. So in order to get the data, we talk a lot about technologies and sensors and AI and automation, but I want to talk about the people and the processes, which is really what's been successful, what's made us successful at LACCD. And that starts with the facilities planning group like Peggy and James and their vision for the facilities. Utilizing that vision, our program management group can help design and build the buildings. We have a team of dedicated program managers and subject matter experts that are solely focused on digital buildings, engineering, and technology. Through that collaboration, we can start to build the connected facilities and have convergence between those systems, open architecture in place, so that we can start to create the data lakes to share information and utilize it to get the data and insight. Of course, we work closely with our energy and sustainability partners and try to ensure that the buildings are meeting the latest LEED credentials and standards and connect to the smart grids and other applications there. And then last but not least is the collaboration and partnership we have with the district's information technology group. They're the ones that have to maintain the network connectivity. We're right now working a lot in determining cloud versus on-premise solutions. And then they also provide the security and the cybersecurity aspects to allow for remote connection and remote access to these systems from either the facilities office or off-site for our third-party providers. So one of the key areas in our processes that's been really successful in developing the connected facilities is our integrated planning approach. We first start with understanding the educational mission, vision, and goals from the academic side and the administrative side. We then incorporate the long-term vision of the facilities master plans. We meet with our technology department to understand the strategy and their plans for the future. And then a big component of is accessibility. Whether you're able or disabled, all students need to have equal access to the academic programs, the classes, and what offerings the district has. And we look at the technologies like assisted listening or closed captioning to ensure that they're incorporated into the connected facilities. We look at the security assessments that's been performed to integrate those aspects into the building, and then we look at funding and resources. And what we're finding is by looking at it from a total cost of ownership perspective and the return on investment of these cost-effective connected facilities, that's what kind of really provides the backup to investing in a connected facility and a digital solution. So we talk a lot about BIM standards and other standards, but one of the big components that we've recently seen change is the telecommunication standards. The rooms are getting bigger. The older components that were in electrical closets or in random shafts in the buildings are now moving into the telecom rooms. So we're seeing growth in that area. We're also integrating all of the facilities components and making sure that they have similar language regarding open architecture and connectivity on the lighting, the energy side, and other sides. We also have specific standards for physical security and AV, and the link is below to see if you wanted to access those. So once we get into design, it's really important we partner with the architects and engineers. We review the drawings, we collaborate with them, and ensure that they're meeting our district-wide standards and meeting the goals of the district. We also review the infrastructure and the connectivity going to each building, which means that all those buildings need to connect at a campus level, and then at the campus, all the 9 colleges need to connect back to the district. And of course, like James mentioned, we utilize BIM to review, look for clashes. We can now see our assets like cameras and projectors within our BIM drawings, and we can then determine if the architects and engineers are going down the right path. So that's been a very useful and helpful tool. And then this is kind of our secret sauce when we come into the integration of all these systems. So it starts on the infrastructure level. We got to make sure the telecom rooms are built appropriately, they're well lit, they're powered, they have clean power, they're dust free. And then we can work with our IT groups to install the networks. So these are the network switches, the wireless in the building, and then the backup power, like the UPSs. We're moving towards lithium ion and actually moving away from the lead acid, by the way. And then we can start lighting up all of the different facility systems like the emergency phones, access control, security cameras, the fire life safety systems, which are now on the network, the energy, the HVAC systems, lighting controls. We have audiovisual systems, and then in some cases, the parking solutions for our parking lots and our structures for car counting. And those are generally the ones we need for substantial completion that are being inspected by an authorized inspector. But then we can then start moving into the end user devices that our occupants utilize. So the computers, the phones, digital signage solutions, point of sale, like in bookstores and cafeterias, and queuing and ticketing systems for our students. So as our kind of final step before we turn it over to the facilities group is we go through a very rigorous testing and validation process. We do test each of those systems individually, but then we look at it from an integrated perspective and ensure that they are communicating and talking in the way that we need them to. And that's all before we actually go into our whole building commissioning. So we resolve a lot of the issues up front before we go into commissioning, and that has helped to allow for the integration of all of these systems and make it easier to close out the building as well. This is the point where we do start to provide access to the building management systems and energy management systems to the district facility staff. And then we can also start to develop the digital twin at this point, so they can visualize the building remotely. I should say that's plural, the digital twins. There's a couple different models out there. And then finally, we can integrate and import all of the building data from the design, the as-built, and into the CMMS, the NUMIS systems, where now our facility staff can start looking at work orders and start performing maintenance, preventative maintenance on that new facility. And so with that, I'll hand it back. Oh, I forgot. I'm not going to go over too much detail, but this is just a quick summary of the software that we're using on the program from design and construction. We have the typical design products there, and we have our project management products. And then we have some energy management products. And then, of course, we have our CMMS and our work order system products as well. So with that, I'll hand it over to James to talk about our facilities lifecycle.
Oh, you're going to do it first.
That's right.
All right. Thanks, Sunil.
Yeah.
You're giving us a whole stack of other information that needs to be integrated into the digital twin. So we're coming at it from multiple directions, which is actually a good way to grow and keep adding, as long as you have that main vision of ultimately we want to connect the dots between everything, right? So we, just a little bit of background. We have our own system called the Onima system, which is basically a BIM server that hosts BIM and data on the web. And we did not intend to become a software company. We did not intend to become a CMMS system, but we had a lot of clients and districts that were saying, hey, we're using this application that's built in the 90s or 20 years ago or whatever. And we're very frustrated with the complexity and the cost and the fact that our data is trapped in a proprietary format that can't be linked to other systems. Can you build something that lets us do that? Because they knew we had that type of capability. So we kind of backed into it from specific requests from the districts. And to tell you the truth, the actual building of the application, it was difficult, but it was relatively easy because we did not have to build the Fusion Lego block that I talked about in the bottom. We built another Lego on top using the same data below, which made it quick to do. And we did not have to worry about, well, how do we get the data imported and synchronized and extracted or transformed or whatever. So we started working actually about a decade ago with different consulting work with LACCD and Build LACCD, but we started this particular project a little bit over a year and 3 months ago, I think, to actually implement. And we did it in a very agile way. We said, first of all, let's build a project website to do all the communication. Let's get rid of as many of the documents as we can, and we're in COVID, so how can we collaborate more efficiently? Let's put things on a website, all the notes, the meeting, the videos, all that stuff. And it's a huge, and we've been doing this for years ourselves, actually. And over time, I think we've developed new ways of doing it. And now it's interesting that the rest of the world with COVID has pushed a lot of owners into this naturally. And this has been a very efficient way for us to work. It was a very aggressive schedule. We started in February with a kickoff. We said, let's set up a functioning prototype first on one campus, 1 out of 9, and train the teams, many different stakeholders, all the way from more technical stakeholders to technicians in the field that knew nothing about BIM but needed to fix that piece of equipment. And that's been always the objective. With these more modern applications, there's no tolerance for something that needs a lot of training. You want to just pick up your app and call up the Uber, so why can't I say that the projector doesn't work in this room and I need a technician here to help me mirror the screen or whatever I was doing earlier. So that was the goal. So within a few months, we had it running. We also had Dabblefox, which is another application that is another Lego in the stack that we actually guided that team on developing it a few years ago. And they built on top of our application, on top of Fusion. It's a custodial planning system that relates to the spaces. And the reason custodians want to know about space, they want to be able to schedule, they want to be able to know how many square feet of carpet is to clean, and a lot of other things like that. So, number one, simple access to information. Pick up an app, say that the lights are off in this room or the water is on the floor, point to a map. That map is a BIM that links to the data about the BIM, that links to the state level, that calls the name of that space, that links to the data that came from LACCD, and becomes a system of systems that talks to a lot of things. The request comes in, the admin picks up the request, they can see what's going on, they can see in real time as the technician responds to it. They can point to the right room if the person in the room pointed to the wrong room number. They can see other assets that are in that room. Where is the air handling unit on this building that might be causing this room to be too hot? And then they also have other views for more technical information. Again, with exact same data, you can keep drilling further and further in. And with other districts, we've actually even gone all the way to linking a lot of their other systems into it, including live sensor data and everything. So it's all possible. All the information that Sunil showed is possible as long as that data is accessible. If they have an open connection, then we can start plugging into it. And that becomes a conversation with the vendors and the applications there. So that's the view of this. And now James is going to kind of talk through how it's actually being used at the field level and the admin view of this.
Right, so the screenshot I think is from City. City was our pilot college, and for the first time we can, through BIM, visualize our floor plans. As Kimon was saying, we have over 700 buildings, over around 11,000 spaces. Before we were just managing that on spreadsheets. Now we can visually see all this information and show it to more people. Again, these floor plans are viewed by faculty members. Now their faculty members, whether they know it or not, are becoming our space inventory team. They're telling us when spaces are being changed, and we can update that. So when we submit to the state annually our new space inventory, it's accurate. And through BIM, also the accuracy of our spaces is really good. As you can see, all the spaces are green, so that's under 1% in terms of being close to what we're submitting to the state. And most of our buildings are in the green. Every once in a while, we do get a building where a few spaces are off, and now we can visually see that and make the corrections, and also have this being viewed by more stakeholders on the college side, which has been in the past harder to do just because you were looking at a lot of spreadsheets. Now it's a lot easier to consume this data just looking at it visually from the BIMs. And again, we're using the BIMs for the assets in the work order system, and it's tying into that floor plan view. So now all of our M&O staff know exactly where to go in the building to take care of our assets. Again, as Peggy was saying, we have a limited staff. We don't have schedulers, we don't have planners. So this is a way to increase efficiency with our existing staff in terms of mapping out where they should go every day, making sure all the equipment's in their cart before they get to the job and know exactly where to go. And then at the same time, be able to apply metrics to all this. knowing that our space inventory is accurate because it's coming through the BIMs. We launched this program back with City with the pilot back in 2021, and in a matter of 8-10 months, we had all the colleges up and running using the work order system, just because the data was upkept, it was accurate, and it was all coming from the BIM. And now we're over 16,000 work orders, and we're hoping to have that number increase drastically as we're increasing the preventive maintenance. And again, we went live back in March 2021 with City. And a big key aspect to this, increasing the work orders, was the mobile device and having all this accessible through the web. And I'm just going to skip some of this. We're also using those same floor plans with our custodial work loading and management. So same floor plans, grabbing from those BIM models, and we're using it to do our custodial cleaning. We're also connecting that data to, let me skip a slide. We're also connecting that data to the class scheduling software, so you can see exactly where we need to go when we're cleaning our buildings. This was critical during the 2 years when we had COVID, where we had to really know where we had to go for the classes and do our cleaning before and after the classes. And again, we're using mobile devices to do the inspections on all of our spaces. And we did this pilot reaching out to the M&O staff and having a big user group and making sure everyone was a part of this process to increase kind of the adoption of heading into kind of this new world of BIM, which can be a little bit overwhelming sometimes. And I think we're done.
Thanks, James. Yeah, one slide that's particularly interesting was this one that showed the green spaces. This one here. So green here means that the data in Fusion matches the shape of the space, right? Which means you're reporting 850 square feet in Fusion at the state level, and you actually have that square footage here.
Correct.
Yeah.
The data reported to the state also came from the BIM.
That's right. The data came from the BIM, so there's a one-to-one match. A lot of the other districts that we see typically have a color-coded map like this because they're not using BIM and they're using tape measures and whatever. But the reason these are off is when there's a renovation or a change to the space sometimes, so it's able graphically to catch it, right?
And I forgot to mention, we are LiDAR scanning all our spaces to make sure the accuracy of the BIM model during construction.
Yeah, so the space inventory is important because it's reporting your actual use, which ties to a lot of other things, not only custodial and planning, but to funding and resources and student counts and things like that, right? Yeah. Great. So I'm going to try and do a live demo here. This is a view of the entire California Community College's Fusion database in the ONUMA system for every single district in the state. So every dot on the map is a campus. That campus leads to an actual layout on a site like this. This is the Los Angeles City College Live. And each building, in this case, we reviewed and color-coded it based on the quality of the underlying layouts of the CAD and BIM files. So the darker green they are, the more accurate they are. There are a few outliers that need review and updating, but overall we found relatively good quality of the layouts of the sites. Here is East Los Angeles College with the background Google Map image on. So this is live data from Fusion. The building name, the size of the spaces, the other attributes are all coming from Fusion into the ONUMA system. Here's Mission College. As you can see, there's a lot of green here. LA Pierce College, LA Trade Tech, LA Valley, West LA. And then if we zoom into one of the buildings on the Los Angeles Mission College, this is a typical layout that's in relatively good condition. And the color coding and the names of the spaces, for example, are coming from Fusion. So if we open up the Fusion tab, you see the information about the top code and the assigned stations and the assigned square footages and the PGM codes. So what I'm going to try and show is what it looks like. What does the digital twin look like from an occupant's point of view to be able to submit a work request, and how the facility manager reacts to that request. Okay. And you can actually try this yourselves if you want. There's a QR code that we have on screen that we're going to look at the LA City College communicating through BIM. Step 1 is a work request. So here's the work request. So step 1 is the occupant sending a work request in. Step 2 is facility manager seeing that, and then the technician responding to that. And that was all the statistics that James showed earlier about what was happening in real time. So I'm going to go through step 1. This is reading live off of the web browser for the request. And the key thing here is, as I do a pull down, it says select the building. The names of this building are coming from the state level server. So we're seeing the actual names of the buildings that could get updated and changed, but this is an authoritative source list that says there's a building here that then pulls up a floor plan in real time. Basically, as I'm pulling down on this, it says, okay, here's floor 1 of that building, what's on floor 2, or select the space or point to the space on the plan, and then it identifies that room. So this number here and this plan here is all the connected pieces with Fusion, with the BIMs, with the location of the plan. And the interface here is basically saying, okay, 1, 2, 3, where are you? What's going on? There's water on the floor. And you can optionally select a type of cleanup request, for example. You can attach an image if you want. You can add your name, which is required, your email address. And phone number, which is required in this case. So I'm going to just put in my office number. And submit. And that basically grabs information from, I guess I'm assigning it to myself. It's recognizing that I'm me, which is okay, actually. We have some technicians that assign requests to themselves so they can have a reminder to go and do that response. So that becomes a request. And then what happens next is we go into, let's get into the actual system itself. Okay, so I'm logging in from the admin's view, looking at the LACCD Studio. This is in the Onuma System Live. And then it's showing all the, and here's a sample site that we just sent a request in, and the admin is seeing a list of all the requests coming in. They can then assign a technician to it and then track the progress of those requests. So there's the water on the floor request. I click on that, see what the information is, open up the details if I want to see the details. So the point here is that each different stakeholder has a different view of the data. The admin can see the same location, so when they click on location, it opens up the plan. The admin has additional functionality where they can go and look and see if there's any assets associated with that. They can then assign that to a technician and track in real time what happens. That's the part of this is why this is a digital twin. It's happening in real time on top of the BIM, interacting with lots of other users and giving each user a specific view and access level. I can't, for example, go in and change the information about the room number there because that's controlled by the state level and the district itself that's declared that room is machine room 121 in building CDCA, Child Development Center A. And the BIM plan is coming from a full BIM, but we only needed to see a simplified plan to find the location. So that's kind of the sequence of the process here. Any comments from you guys about that? Or
No, just it's really easy for the technician to add a component if they need to add one right away. And then we can do more tracking on our assets.
yeah, your point earlier about the occupant being able to essentially update the space inventory is the same thing with the technician. If they notice something different, you're seeing in real time they're saying, well, this room number is different, or
Correct.
I saw another asset here, or this room number no longer exists, or that doesn't match the door, or whatever.
That's the go. So also, we're going to task our technician to become an asset inventory expert. Usually that's a task that's done by a specific person. Obviously, we're not staffed at that level. So, this is how we're going to use the technology to kind of update our asset inventory.
Right. So it would be interesting to hear your vision of where this is all going. Where do you think this is going to go next? Not just with us, but just in general, the bigger vision of what LACCD is going to do. What's next?
Sustainability is going to drive the next phase.
Mm-hmm.
What do you think?
Yeah, sustainability and connecting more to our energy management system, BIM system.
What do you think the challenges are going to be in doing that?
I think it's going to be leveraging the open standards. We have 9 colleges. Each college is slightly unique in terms of what type of manufacturers are using and systems. So just have an open standard to consolidate all that.
What did you think about the other sessions about the open standards? Do you think there's something there that can be used, or do you?
It can definitely be used. It's just having the staffing to manage all that.
Yeah, there was some discussions yesterday in other sessions about open standards, and sometimes there's a negative kind of view of there's too many standards or being constrained, or how much standards do we need? Are we doing too much, too little? What's the right balance? Any opinion on that, or?
Yeah, so I think that they need to be flexible enough to allow for newer technologies and the ecosystem to grow and incorporate those new technologies. I think on the standards perspective, there are certain ones that should be prescriptive, especially if they have it ties into a direct goal for the district. And then the other ones would be more flexible, especially because we still want to keep the unique capability of certain campuses, unique to that campus. So it's going to be a balance on the scale, and we've kind of done some district-wide standards, and then we also have campus-specific standards as well. They get incorporated in each of our contracts that we put out there.
Mm-hmm.
So it's kind of a balance.
And going beyond sustainability, I think safety and security is going to be the next one. Security, active shooters, and fire alarm systems and cameras. That's going to be, unfortunately, the next one.
Yeah.
Another big one, which is always continual, is just educating our AE firms on the BIM standard.
Mm-hmm.
And come on, now that we have you on board, that's going to help us out.
I'll try my best. And National Institute of Building Science, Roger, do you have any view of what you heard here?
Well, it's very interesting to see the application of processes and how you've organized information to take advantage of those structured processes. So that's good as far as standards go. I mean, we would certainly like to see where the standards that are out there can help you to benefit from what others are doing. I think the area of security is really interesting, how you make the information accessible but also protect it. I think standards can really help there. And then of course, the standards for the models, I think you're probably already making some use of getting that information in a way that you can rely on it. I don't know how your system for looking at models integrates with the data, and what role standards play in that, or they're using the capability of the proprietary tools for integrating the visual and the data side of things. That's interesting.
Yeah. And we had some discussions earlier about IFC and the use of IFCs, and I don't know, James and Peggy and Sunil, as models get delivered from AEs and you have Revit versions, the versioning is a difficult thing to go back on, but if you have an open standard IFC, have you explored that at all, and what challenges are there with?
We have our challenges. We have over 600 buildings. They've all been BIM, but they've all been BIM to a different level. And quite a few of them are still AutoCAD architecture. They're not Revit, so we're using them, as you see in the floor plans, and getting our space inventory. But eventually we got to make that next leap forward and kind of standardize one.
I was curious about how you're using scanning to, augmenting the models with scan data, or?
Yeah, so we're LiDAR scanning the spaces, and as we get that, we double check with the CAD model, and we update the space if it's slightly off. That square footage thing gets connected to Fusion, to our space inventory, and we update the space in square footage.
So getting that scan data into a model in a consistent way. I don't know if you've got these older models and then you start to do the scanning, and that's a challenge, I guess.
Yeah, to be honest, we're doing that more with the new models. So as we get the new buildings online, in construction, we're actually scanning just to make sure all the systems and everything is matching up to the Revit model.
It's amazing how close they are, actually. That's one thing we noticed.
Close, but there's been situations where we saw a wall that was a foot off.
Yeah.
And we were able to make the correction.
Yeah, and I think that with the existing facilities, trying to figure out what level of detail do you need in a model to make it useful for what purpose is interesting.
Yeah, so that's the beauty part of the Onuma system is we have a very rich model data, but we pick specific type of data depending on what we're going to use it for and then the user. So it's, I think, the key leverage point of using the Onuma system.
And I know the next step that we're at right now is figuring out the asset attributes that are important as well as we get the assets in the system. And I think that's one area that maybe the connection with NIBS and the standards is sharing with other owners what type of asset attributes are important. And
yeah, the omni-class classification, all that is huge. We have over 10,000 assets, so to have all that classified the right way so that we can manage it and query it is critical.
Mm-hmm.
Once assets are in, we're going to put them into the preventive maintenance module. So the number of work order requests is going to spike further. That's what our view, hopefully. Yeah.
And then we'll have to strategize which ones are more critical than others.
But also that information will inform the schedule of maintenance for projects in the future.
Correct.
Mm-hmm.
So it's a win.
Yeah, it's the interoperability of the data, but also the consistency of the data and having it kind of clean and manageable.
Yeah,
You'd be surprised if something as a boiler gets named 5 different ways. And you want to kind of make sure all that's kind of categorized.
It's challenging to blend together those different levels of the technology, I guess, if we had standards. I mean, you have to start somewhere. So starting with, because this could be the problem 5 or 10 years from now. The technology will keep advancing, and then they'll say, well, the models that we have are not working the same way as the ones we're currently using. So I think thinking about what's critical to standardize, trying to standardize is a way of looking ahead.
Exactly.
But starting now, and then you can try to bring the older things up as you need to, and in whatever minimal viable way you can do it. That's an interesting
Yeah.
It's interesting seeing faculty and M&O staff using BIM. Granted, they're not opening the Revit model, but they're now visually seeing the floor plan and all that kind of stuff. And in a way, they are using BIM. And it's a good kind of stepping point to eventually get them to use the BIM and open the BIM.
But they're a valuable sensor in the ecosystem because they're giving us direct input
Exactly.
at that location.
Roger, I have a question. So you see the possibility of the data needing to be refreshed because the technology advances? For instance, a BIM model that we had probably 10 years ago doesn't have the level of accuracy than what we have now. So do you suggest that we take a look at the old models once in a while, every 5 years, every 10 years, and then refresh them or make them more accurate?
It seems like it's more on an opportunistic basis. When you need to do something, then you refresh the model, but maybe trying to have a standard for what you're trying to get in a model that you're going to continue to use, and then separating the critical data from the geometry aspects of it's another, I think, important way to organize what the strategy of dealing with the older buildings and then trying to stay consistent with the newer things you're doing, and having a process for that.
Yeah, the Digital Twin Consortium had a good way of describing it. It says you ask the digital twin, what's your job? So it's almost like a person. What are they going to be doing? So in the scenario of the older models, they're kind of a snapshot of what happened 5 years ago, but they might be resurrected to do a renovation. Say, now we're going to renovate this building. Let's get the latest known version of this model from 5 years ago, and then let's look at the history of the work orders and preventive maintenance on that same building, and let's hand that task to an AE to renovate using this historical data, knowing what it was like 5 years ago and knowing that we're getting a lot of preventive maintenance and work orders on certain parts of the building that are falling apart that might need to be fixed. That's kind of my view of it, that if we break it into pieces, then we don't necessarily have to have, because I think that's one of the bigger mistakes that are happening in the industry. There's a misconception that we need to maintain the full model as a digital twin, which is very expensive to do. Maybe eventually we'd get there, but in this scenario, it's kind of a hybrid. What's the best approach using the resources that we have and what we want to ask that model to do?
Yeah, I think that's kind of what you're saying, Kimon, is that the space inventory becomes really important, because then you can see what changes incrementally, and then periodically you have to catch up with it. But if you know what spaces are there and what uses there are, that's a lot easier to keep up to date. And then tying that back to how it fits into the model, what's the plus delta from when you last updated the model based on what's happened to the space inventory, if those can be tracked together.
So everything hinges on our space inventory. That's where we focus most of our effort to make sure it's up to date. All the assets are connected to the space inventory. Our staffing levels now all of our energy calcs are going to be correlated to that. So that's the number one area we focus the most. Then we branch out to the asset, and that's where we're bringing the improvement on some of our older buildings, just because they're not Revit models. They're just the CAD models, and they don't have the assets in there. That's just living in a spreadsheet.
I would think there's
but now those assets are finally at least in the workforce.
Yeah. Space inventory message, I think, is an important one for the other owners that we work with. I think, Roger, right? That's always a struggle. It sounds like a simple thing to do, but it's not simple unless you have a strategy to do this.
So again, we don't have a person that's specifically tasked, let's say, to walk all the building, walk all our 10,000 spaces, and verify that it's there.
People change things. They don't think that it's a small thing. It doesn't get tracked.
But But the nice part now is every faculty member, I mean, every M&O staff on the college, when they submit a work order ticket, they're looking at that BIM floor plan. So they can easily see, okay, this room changed, the room number has been updated. We get a ticket on that, and then we can update the spacing.
I think we actually added a category to update the space number or something. We have these pull-down categories.
Yeah, we had 2 categories.
Yeah, we added 2
one
categories.
On the floor plan, and one on the room.
Yeah.
I would think that'd be a place where IFC would have value, would be that when you can start with a good IFC file and then keep it associated with the building, you're not as dependent on Revit or I don't know if you use Revit for everything, but you end up with files that you can't use because of the software. If the standard version's there, and it's got the basic information.
Yeah. You didn't mention, James, but the connection to Esri and the GIS you have too, the space inventory is aligned with that as well too, right?
Correct.
So it's in GIS.
But by re-leveraging more the IFC specifically for the spaces, that's something we should probably. I don't want to say we already looked into it. We actually have a lot of spaces IFC, but we don't have all the spaces. I think that's kind of the next push.
Mm-hmm. As a deliverable for new projects, just making sure you have that IFC and it has a space number.
Yeah, they could be one of our projects.
Yeah. Again, the tough part is when you have models with all that information, and then you have a lot of ones that didn't want that. So how do you look at it from, I guess, a district-wide perspective?
Mm-hmm. Yeah.
I was also wondering about the data from meters. Are you associating the energy use in rooms back to the room level, or?
Yeah, so that's part of the building automation systems and the energy management systems.
Yeah.
Yeah, I mean, to get into that granular level is what they're aiming to get to. Like what was mentioned before, the sustainability and energy management goals are kind of more recent, but that is definitely where they're going to go. So we're putting sensors individually in rooms to be able to get it down to that level.
But it's located back to your model, ideally, I guess, so that
Exactly.
you can see it as well, test it.
Exactly.
But all of our buildings are metered. No, we change it. Our department changes it.
But you're saying that you don't know what.
Oh,
So
the main M&O or somebody changes.
Who is that?
So we have 9 colleges, over 10,000 spaces. It's kind of hard for us as a department to make sure everything, what's going on the colleges. So this is an easy platform to know when, let's say, a space gets subdivided. I get notified, and then I can make the change.
I understand that. I don't understand how the change happens.
The users could be, it could be the users that all of a sudden they have, let's say, a warehouse and they say, we want to do a little office here, and they kind of build a little
Well, I
office.
think it's also, it's LACCD, we're a district, but we are, what's the right word saying?
Yeah, so we are LACCD, but we have 9 colleges. And
We are decentralized.
we are decentralized. So each M&O office has control of their campus. So it could be that in one campus, they decided, a faculty member or staff decided to do an improvement of their space, and we don't know about it. So then when we have the ticket, that's when we figure out,
There's no way to improve that protocol or the contractor that is being called, because there's a contractor.
Some of that type of improvement is done in-house.
There's actually even other types of changes too, where they might change the room use. It might be the exact same geometry, but it's no longer a classroom. It's a
That's a good
storage.
point. So when we report to the state every year, we report our spaces, but also what's the use of the space? Is it being used as a classroom, a laboratory, an office? Sometimes that space use gets changed. And those are the primary ones I get when a space gets changed to an office and someone needs a new computer or something installed in that office. I would say the tool, hopefully the tool is going to be used more to force collaboration between everyone. Yeah, I can update the revenue.
Yeah. Or we even see it, those red spaces that you saw off to the side. If the space inventory says this is a space 101, but it's not in the model, it places it automatically off to the side as a block. And in this particular use, you're not editing in Onuma usually, but we have other districts where we actually go and grab that space and move it into position. So there's different, and the tool that we're showing, you can actually do editing on screen with the right access level. So it's not just for viewing. But definitely, if Fusion at the state level is an authoritative source and somebody's going through an inventory in the building and puts an extra space or a space that's missing, it'll show up automatically on the plan, but off to the side. Here's 1,000 square feet. The user that has the right to edit it can decide, well, I'm going to move it in, or I'm going to trigger we need a Revit update. Update the Revit model and push it back in. So there's definitely a process that we have in place, but the main thing is that you have a dashboard that shows you all what is known, and you can see the changes. Some of the minor changes of switching the room names are automatic in a sense because we'll get a work request that says this is no longer a storage room, we're using it for whatever, utility room. Then we'll say, okay, we have to report that up. And in fact, we had an example like that where the Fusion data had to be updated, right? So somebody on site said, this is no longer an office. Can you change that room number? He said, we can't change it in this interface, but you have to go back to the Fusion, report it here. And when you report it there, it automatically shows up here. So we have definitely a chain of who owns what and what edits can happen. And it kind of varies. LACCD has one way of doing it, but we have other districts that have different users that go in and change it. So it's really about how much can we get to that digital twin real-time view, and then how much can we allow edits to happen. And you obviously don't want to, if you're having a major renovation, then yeah, you should have a contractor in there that's contracted to deliver BIM. And most interesting thing too is if you give the contractor the known model that we showed earlier, here's a building with the room numbers in it, output a Revit model with that, those IDs will track into the Revit model and they'll renovate. And the idea is to bring it back in, or if they add new room numbers. So there's all kinds of workflows around that authoritative source data. And each owner is going to decide how they want, which tools they want to use and how they want to do it. But ultimately is to get that one view of everything.
And another same example that hopefully by visually looking at this data more, you don't have to add that room.
Yeah.
If I already have that room, you just didn't know you had it. And having those type of
Yeah, so.
And visibility into everything that's there too. Right, there's another place they could do this if they just thought about it.
Correct.
Yeah.
So we actually upload all that information before we handle it. Once the building's built, because remember we already have we have the BIM model.
No. At closeout, yeah.
At closeout.
In our process to close out a project, all the closeout documentation needs to be in place. So that's in one of our forms where we'll have the BIM team verify the final record drawing Revit model to see if it's in compliance. Yeah.
So it's kind of an officially.
So we're receiving that
different stages.
So, and it starts already in the program phase. So we'll do it in schematics, the DD. Yeah, 50% CDs, 100% CDs. We're each one of those steps we're checking.
Yeah, during the design development. Yeah, if in the contract with the A&E firm or the design build firm, there are different deliverables, and that schematic design development goes from CD, 50% CD, 75% CD, 99, and then 100%.
And then hopefully in construction there is not a lot of changes.
And then
because you're using the BIM, but there is changes in terms of the assets. Maybe some model numbers, make model.
there's a huge value in that because then the maintenance and operations staff get to see the building while it's being built, know what systems are in there, can start preparing for it. Yeah.
No, they're part of the review process. For instance, I have seen how the maintenance and operations people go and say, no, that HVAC system doesn't work in this area. That's a conversation with the design team, which is really interesting.
I mean, it's how it should.
Yeah.
Yeah, for us doing it now for 10 years, it's just getting the A firms to deliver their models consistently. Because depending on the firm, I guess iteration.
It's pretty inconsistent.
So that goes back to the 10 years. You need a project to last 10 years.
Yeah, especially when you start adding, verifying for the Omni class or the IFC.
Yeah, back to your earlier question, I'm opening that same plan, and I have the right to edit it here. And this is not how LACCD does it, because we get it from the Revit model, but we have other districts that say this space is larger or smaller, they just edit it right here. So that also, but the name of the room and the square footage of the room is coming from the state. So if somebody edits it here, it's going to turn red and say you're no longer in alignment with the official number. But if they want to update the official number, you could update the inventory. So that's why the space inventory kind of is critical to all of this. If you have the space inventory, you can start landing other things on top of it. And then if there's a major renovation, or even in minor ones here, we wanted to update it in Revit, so the Revit model is in alignment here. So we have the IDs here online matching up with the IDs in Revit and in the GIS. So if the GIS gets updated and we import it back in, it matches the IDs and doesn't break the link to the other data. So there's this whole ecosystem of the digital twin, the thread, or the golden thread as they call it in the UK. It's all kind of interconnected.
At least you have an interface for that. I think a lot of owners have
They don't, yeah.
capability where the changes happen and they don't get updated because there's no real integrated way for them to go in and say, we moved this wall and changed this space and have it be integrated into the
That's right.
plan system.
Yeah. Yeah. So the intent here was to make it as simple as possible to go in. If you have the right to edit it, but still be linked to the full Revit model if you say the Revit should take the lead. But most owners don't have a Revit team after Revit goes away, so you want to at least be able to move a wall, but you still want to connect the ID to the source file. That's right, yeah. Exactly, and that's why the work order system is interesting, like James mentioned. If they say this is no longer room 101, it's no longer a storage room, we get a request in, and then we say, oh yeah, this room has changed, and we have to update the attributes about it. So it's really trying to be as agile and flexible as possible, but with still strong rules around who can edit or not. So for example, if I take all these spaces and I delete them from this plan and I refresh, they'll show up again because they're still in the space inventory. They'll show up as blocks.
Yeah, the other aspect that I mentioned was we have interns. So we have CAD, we have architectural department, engineering department. We grab students every year and they do an internship to help us out with the BIMs, with the GIS. Mm-hmm. And now with the UMA system, we're going to expand more and more on kind of the roles.
So I think we're at time, but you have one more thing?
I have one comment going regarding how the path to the future. One of the things that I see besides sustainability and safety is also the natural hazard. So that's something that we should also consider. I know that these two things are very important, but we have to also look at, we live in California, it's an earthquake-prone area. And ideally, that's what I dream, is to have our buildings seismically instrumented so that you know at real time how is their performance, because we already have a BIM. We can have the dynamic performance of the building. And it's not only because it's cool, it's because it can provide safety to the users. You can tell them, well, this area of the building is safe, you can stay there. Also for business continuity. Sometimes the people are panicked after an earthquake and they evacuate the area, and it could be that you can the building is safe. You can continue working on there. So that's I think the next round of things.
And
So
within
that's the cross pollination between all your departments.
And as we tried to do some work with THS on resilience and how to objectively identify resilience and then evaluate different buildings on a common scale so you could see in your building portfolio where the risks were, and then you could try to manage at that level. Ideally, that would be tied to the model because you're trying to measure the building's susceptibility to collapse or to the earthquake activity or flooding or something, but then put that all together. That would be really a neat thing to be able to do with a model. I think there's some things out there, but none of it's connected together to scale resilience and associated with the building.
And actually,
another aspect I didn't cover, really interesting, is we're talking a lot of BIM about the building. We also have this whole other area which is outside the building and the infrastructure and your walkways, parking lots, and roads. Love to leverage the data and use it, for example, ADA path of travel. What's the best route for someone to go from where they park to their classroom?
Yeah, that's what I think people are trying to work with GIS to do that kind of stuff with the ArcGIS indoors and integrate the site planning, access and egress.
It's actually all closer than we think because the scheduling data we already have access to schedule the just custodial cleaning of classrooms based on real-time use of the rooms, which means that you can put a point in time and say at this point in time, if something happens, what do we tell the people in this room? And tie it to a GIS. In fact, this morning they had a GIS demonstration at the Digital Twin Consortium where they had climate, when a storm came through or whatever, what happens to the city or this part of the city. If the buildings know what's in there at that time, and then you have real-time weather data coming on top, it means that you can trigger a reaction. Stay in the building, get out of the building, all that stuff.
For instance, the other thing is floods. Some of our campuses are exposed to floods.
Yeah.
So maybe it's the flood is coming. You have everything, the BIM models, and then you can say, well, this area needs to put a temporary barrier or something like that. I don't know. I think there seems to be a lot of things that we can do with the BIMs models.
And if the data is accessible, like we talked about in those Legos, it's really not that far of a stretch to build an functionality with current tools to do a lot of that. Just like we did with Dabblefox, basically, building it from scratch. We ran a little over, but I think we're good, right?
Thank you.
So thank you. Thanks, Roger, for your input too. You joined the panel, I think.
It's really interesting. It's been a real opportunity for me to see what Kimon does in his spare time when we're not working on the projects we're working on. So that's been great, and I can see the application of those concepts that we use to try to organize information, standardize it, and have good internal standards, but then start to figure out how to introduce the open and external standards so that it makes it more durable and allows it to work with other systems more efficiently. And allows you.
I think even the government agencies we work with, they're not going to necessarily use the same applications here, but the use cases are exactly the same and can learn on how to train their teams to do the same thing, I think.
So Roger, we're open at LACCD if you want to visit us or if you want us to become a pilot for some of your projects. We welcome your ideas.
Well, we were talking about that there could be an opportunity. We just signed an MOU with the Digital Twin Consortium, and they're interested in what standards are needed. They want to look at uses and determine what standards could be needed or provided to support the different use cases that exists, and so there might be an interesting way to have a pilot project with you. They have, I think you guys talked a little bit about that, right?
Yeah, we did. Yeah.
They're doing some things here in Orange County, so that could be interesting.
Yeah, and we didn't talk about it a lot, but we do follow APA a lot. We have a lot of APA standards.
Oh yeah, APA. They just
Coming
did
out
this
with
new TCO standard,
TCO,
which we worked with the person who led that, and he's really interested in how to introduce costing in with the modeling. We're also interested in that for our federal agency owners, so that could be another interesting area. Yeah, so it'd be great to, I'm glad we were making this connection. We need to do something together. It's good to see the progressive approach you're taking, addressing your needs of the environment.
Thank you, guys. Thank you.